Hello, Algebra 2 students. Miss Huss here again. Yesterday you learned about three rules: product, quotient, and power. If you didn't watch that video, I need you to go back and do that first because you're going to need those rules in order to be successful today. We're going to build off of those to learn two last rules for exponents here. So we are going to get started. You need to either find yourself probably that same paper that you worked on yesterday if you use your own scratch paper, or go ahead and print off the note sheet that's attached to Google Classroom. Here we go. We're going to get started. So pause if you need to, otherwise here we go. Alright, so up at the top, we're going to take a look at using some of the patterns that you already saw yesterday in order to find the rules here for zero and negative exponents. So this very first problem here starts as x to the third over x to the third. And if I look at that, that's set up right now as a division problem. And so using that quotient rule, I can subtract 3 minus 3. And using the quotient rule, that gets me to x to the 0 power. Now, we're going to build on to what that 0 rule is. So what happens when a base of x or a base of anything has an exponent up there of 0. Now you can't really expand out x to the 0, but what I can do is expand out the problem that we started with. So here I had x to the third over x to the third, and so I expanded that out by writing 3x's multiplied on the top over 3x's multiplied on the bottom. And what's going to happen here is that I can make some giant ones dividing x by x 3 times, like what we did yesterday. And so when I do that, all 3 of those x's divide to make 1, and so what I'm left with is just 1. 1 times 1 times 1 from those 3 pairs of x's just gives me an answer of 1. And so x to the 0 power here doesn't equal 0, it equals 1. What I'm going to have you do is I'm going to have you pause the video and do that same thing. So start by using the quotient rule to subtract those next two exponents. And then expand out that original problem to see what do you end up with. So pause, answer the question, and then hit start again. All right, let's check what you did here. So again, I've got y squared over y squared, which gives me y to the 0. And if I expand out with 2 y's on the top and 2 y's on the bottom there, I can make ones dividing y by y to get 1 and y by y to get 1 again. And those two ones multiplied together just equals 1. You're probably starting to see a pattern here. So x to the 0 equaled 1. I circled those here, and now I also know that y to the 0 equals 1. You're going to see I showed the work for the next problem as well. 6 minus 6 on those m's is 0, and then expanding out to all 6 of those m's on the top and the bottom, again, gives me 1. So what's going to happen here is anything to the 0 power would kind of work out this exact same way. You're going to notice that when I simplify the answer for all 5 of those problems, when I do 1 million to the 0 power, still 1. If I did negative 2.467 to the 0 power, that also equals 1. Anything to the 0 power, letters to the 0 power, like b to the 0, that also equals 1. And so I want you to think about what the rule is here and answer the question that pops up. All right, let's fill that in here. So anything to the 0 power equals 1. And so that's going to be called the 0 rule. Anytime you see that, the thing that is raised to the 0 power is what equals 1. Okay? All right, let's build using that same idea, the negative rule. So I'm going to look at the next box there, and I start there with x to the third over x to the 7th. And if I subtract 3 minus 7, I end up with x to the negative 4th. Now, I can't logically expand that out because how do I write something repeatedly multiplied negative 4 times? And so what I'm going to do instead is I'm going to expand that problem that you started with up here. So you're going to see here I've got 3 x's on top and 7 x's on the bottom. And what's going to happen is you're going to think to yourself, how many x's can you make ones out of? How many can you cross off using that giant 1 rule? And so there I'm able to cross off 3. And so I'm left with 4, but I'm not left with 4 on the top, I'm left with 4 on the bottom. So what you're going to notice here is that using the quotient rule, x to the negative 4th is equivalent to using expansion 1 over x to the 4th. So I kind of circled those there. Those two things are equivalent to each other. Okay, This time I'm going to keep working with you, but if you feel like you can get ahead of me, go ahead and pause and do that, and then check your answers. I'm going to keep going here. So let's use that quotient rule to do the y's. I do 2 minus 10, and that gives me y to the negative 8th. You're always subtracting the top minus the bottom. And so then I'm going to also show expansion, so 2y's on top and 10y's on the bottom. I can cross off two of those sets of y's rather, and I end up with nothing on the top left over, but since we're making giant 1's out of those y's, I end up with a 1 on the top, and I end up with 8y's left over, but those 8y's left over are on the bottom. So again, I circled y to the negative 8th is equivalent to 1 over y to the positive 8th. Okay, now I want you to pause and try one more time with the m's. All right, let's see what you just did. So 4 minus 5 gives me m to the negative 1. When you go ahead and line them all up, expand it out, you can cross off making 1's out of every m. You're going to end up with just 1 left over on the bottom. So again, that m to the negative 1 is equivalent to 1 over m to the positive 1, or just 1 over m. So we're going to use that same idea here, noticing the pattern here, that x to the negative 4th, I flip to be 1 over x to the positive 4th. Y to the negative 8th, I can flip over to be 1 over y to the positive 8th. M to the negative 1, I flip that m to be 1 over m to the positive 1. So here, if I start with b to the negative 12th, same way, I'm going to flip that to be 1 over b to the positive 12th. We can also go the other way. This time, if I'm starting with 1 over y to the negative 7th, I flip it the other way. I'm sort of starting down here. And what happens is that's going to turn into, I flip the 1 over y to be y over 1, and then that negative 7 can become a positive 7. Let me show you why that's true, why that works. We've already established here that that y to the negative 7th would turn into 1 over y to the positive 7th. So essentially what I have there is I have 1 over y to the 7th. And when you're dividing by a fraction, it's the same thing as multiplying by the reciprocal, which is y to the 7th over 1, or just y to the 7th. Last piece here, this very last fraction has 3 parts on the denominator. It's got a 2, and that 2 has an invisible 1 exponent. It's got a g to the 3rd. Now that 3rd exponent is positive, and then it's got an h to the negative 5th. So you're going to see that I underline that one in red to show that that's the negative. You only want to flip bases that have a negative exponent on them. And so that 2 to the positive 1 stays on the bottom. That g to the positive 3 stays on the bottom. It's that h to the negative 5th that's going to flip from the bottom denominator of your fraction up into the numerator. You're going to write the reciprocal to get that negative 5 to be a positive 5. And we want to, whenever possible, eliminate negative exponents. I'm not going to have you guess the definition here. I'm going to go ahead and show you what I want you to write for the definition here. So a base that has a negative exponent is equivalent to the reciprocal of the base to the positive exponent. And reciprocal, remember, is a fancy way to write like the fraction flipped. So shorter verbs here, shorter definition is to flip your base, flip the fraction, and then change your negative exponent to a positive. And this is called the negative rule. Okay, what you're going to do in a second is you're going to pause the video. You're going to do on the back side here the 8 practice problems that I gave you. You're probably going to make some mistakes as you try these, but again, didn't mean to show you an answer already. Again, you learn more making those mistakes and then fixing them than you do just waiting for me to do it for you. You won't learn very much if you just press play and see the answers. So go ahead and pause. Please give these a shot. The one thing I'm going to tell you is, again, you still want to use that power rule first when you can. So when there's parentheses with that exponent on the outside, you want to do that power rule first. And then you can use your other rules, product, quotient, negative, and 0. So give it a shot. Try them all. You probably will make mistakes. That's okay. And then go ahead and press play again when you're ready. All right. I'm going to go through these kind of quickly, and then tomorrow you'll have a chance to kind of practice all of this. You won't be learning something new tomorrow, and we'll be having some office hours so that if you're totally confused, you can come talk to me or Miss Yosea and get some help on exponents. So here we go. First one, letter A. Starts with the power rule, and in fact, that's all you have to do. So I'm remembering yesterday, you take that 3 on the outside of the parentheses and distribute it with multiplication into all of the exponents that are in there. So that's going to turn into x to the 6th and y to the 12th, multiplying 2 times 3 and 4 times 3. Nothing else you can combine there, so that is as simple as that goes. On letter B, the first thing you want to do is treat normal numbers like they're normal numbers. So I want to look at the 2 over 8 and think to myself, is there anything that I can do to simplify the fraction 2 over 8? In your calculator, you can do 2 divided by 8 and press math enter to reduce it. Or you can think to yourself, is there a number I can divide both 2 and 8 by? And you can divide them both by 2, which turns that into 1 over 4. And then I'm looking at the fact that I have 12 x's on the top and 2 x's on the bottom. You can either think of this as subtraction using the quotient rule, or think about all the x's you can cross off. If you have 12 x's on top, 2 on the bottom, you can cross out 2 and you're left with 10. Okay, so you've got 1 over 4 and then x to the 10th, and I just chose to write my final answer without that 1. In letter C, there's kind of 2 options. You can deal with the negative first and flip that x to the negative 2 to be 1 over x squared, or you can just go ahead and use the product rule, which said when you were multiplying 2 bases together, it's the same thing as adding the exponent. So if you just add negative 2 plus 5, that's going to get you x to the 3rd, or you can also flip that x to the negative 2, put it on the bottom, and then subtract with the quotient rule, but you should have ended up with x to the 3rd. On letter D, I dealt with that negative 2 first, so I flipped that y to the negative 2 into the denominator. And that gave me 1 over y squared y to the 3rd. Again, once you flip that y to the negative 2 into the bottom, that negative 2 becomes a positive 2. And then you're going to put the y squared and the y to the 3rd using the product rule. Adding those exponents would give me 1 over y to the 5th. You also could approach this a different way if you wanted to. You could subtract your exponents. So negative 2 minus 3 would give me y to the negative 5th. And then if you flipped that, you'd get 1 over y to the positive 5th. Okay, letter E is going to start with reducing 14 over 21. Think of a number you can divide both of those by and then do it. I can divide those both by 7, and that gives me 2/3. So 14 divided by 7 is 2 on top. And then 21 divided by 7 is 3 on the bottom. And then I think about, you could do subtracting with the quotient rule, or you could think about expanding that out. How many A's would be left where? How many B's would be left? Where would those be? You're going to end up with reducing that 14 over 21 to be 2 over 3. You're going to end up with 1 extra A on the bottom and 1 extra B on the top. So you've got that 2B on top over 3A on the bottom. On letter F, you're going to start with a power rule, distributing that exponent of 3 into all of the bases inside, knowing that 5 in the front has an invisible 1 exponent on it. And so when I distribute that in, I get 5 to the 3rd, p to the negative 9th multiplying, and r to the 6th. Keeping in mind that 5 to the 3rd is not 15, it's 5 times 5 times 5, giving me 125. And then that p to the negative 9 needs to flip into the denominator, reciprocal down into the bottom, and then that 9 becomes positive. Everything else has a positive exponent, so it can stay in the numerator. G and H might look to you like they're the same problem, but there is a slight difference. The 0 in G goes to both the 4 and the Q because of those parentheses. And so that 4Q is raised to the 0 power, and we said anything raised to the 0 power equals 1. The difference here on H is without those parentheses, that 4 has an invisible 1 exponent on it, and so that one doesn't have a 0. The only thing that has the 0 is the Q, so this is really 4 times 1, or 4. Now, as I said, if you made mistakes today, seriously don't worry about it. We wanted you to do that to learn. Tomorrow, if you have questions, you'll come to office hours, hopefully, if you can, or email us, or we'll post slides for those. And then we'll get all of your questions answered. Thank you, guys. Bye.